Assalamualaikum and a very good day to our lecturer Miss Noratika and to everyone watching. We are from Group 1. So today we are excited to present our video assignment for Maths 438 where we will be breaking down 3 distinct calculus integration problems. Before I start, allow us to introduce the team behind this presentation. Our group consists of 3 members. The first one, Noor Aisha, who will assign the question 1. The next is Noor Alia Balkis, assigned to question 2, and Mas Rina will cover the question 3. Let's begin with our first question.
Assalamualaikum. My name is Noor Aisha binti Ala. I will explain the question 1. Evaluate the integral using integration by part. As you can see, this is my equation. For this step, I use table method. First, I separate the integral into 2 parts using the addition property of integration. This makes the problem easier because I can solve each integral individually. As you can see, I identify x squared, which is algebra, and sin 3x as a trigonometry hyperbolic. Because of A go first and follow with T, so I choose the table method. Step 1. Construct the table. In the first column, start with plus. And for the left column, for differentiate, and right column for integrate. For the first integral, I use the tabular integration by part method. I repeatedly differentiate the polynomial x squared until it becomes 0. At the same time, I repeatedly integrate sin 3x. For the right column integrate, keep integrating, which is sin 3x. This shown the first integration, second integration, and third integration. For the signs, I assign alternating signs starting with positive, then negative, and positive again. This sign comes from the repeated integration by part formula. Step 3. Multiply diagonally. I then multiply the term diagonally according to the table and combine them with the corresponding sign to obtain the antiderivative of x squared sin 3x. As you can see, we have first diagonal, second diagonal, and third diagonal. Step 4. Combine all terms. I combine both antiderivative and simplify the cos 3x term to obtain the complete antiderivative. And the last step is step 5. Include the plus 6 term. I apply the upper limit x equal to 1 and lower limit x equal to 0 to the antiderivative. After substituting x equal to 1, obtain x is 1, then I substitute x equal to 0 using cos 0 equal to 1 and sin 0 equal to 0. To obtain x equal to 0, finally I subtract x 0 from x1 to get the value of the definite integral. After all the substitution and simplifying, we can get the final answer, which is x squared plus 6 sin 3x dx equal to x squared over 3 cos 3x minus 2x over 9 sin 3x plus 2 over 27 cos 3x plus.
Hello everyone, so next question is question 2. I will explain one by one and step by step. So this question is about trigonometric substitution. So the first step, choose a suitable trigonometric substitution, which is, in this question, we have 16 plus 9x squared, square root. Next, the x will be given, which is 4 over 3 tangent theta. Next step, differentiate both sides. So after differentiate, we get dx is equal to 4 over 3 secant squared theta d theta. So the next step is second step. We have to simplify the square root. X is equal to 4 over 3 tangent theta into 16 plus 9x square root. Rewrite 16 plus 9x squared is equal to 16 plus 9. Replace the x with 4 over 3 tangent theta squared. So continue next. From here, we factorize this. factorize. So next, step 3, draw the triangle each opposite adjacent. So we know that x is equal to 4 over 3 tangent theta. We obtain tangent theta is equal to 3x over 4. Tangent is 2, so this is O and this is A. The opposite side is 3x. We just rewrite on this right triangle. And next is adjacent side is 4. So we have to find the h, which is so we can simplify 3x squared plus 4 squared. So we get 9x squared plus 16. 16 plus 9x squared and dx. Alright, so we just rewrite back over 6x for dx is equal to 4 secant theta 6 4 over 3 tangent theta. From here we can simplify the constant give. So we get 9 over 32 integrate secant cube over tangent theta d theta. Right. So the integral become a function of secant theta and tangent theta. And the next step is we write using sine and cos. So secant theta is equal to 1 over cos theta, and tangent theta sine theta over cos theta. So we get secant cube theta over tangent cot theta is equal to cos theta over sine cot theta. Thus we get 9 over 32 integrate cos theta sine theta d theta. Alright, so the next step is step 6 is equal to sine theta. Then we differentiate, we get cos theta d theta, and the integral become 9 over 32 we substitute this cos with u. Alright, so from here we integrate 1 by 1. U negative 3 over negative 3 is equal to negative 32 u plus c. Alright, and then substitute back u is equal to sine theta negative 3 over 32 cosecant cube theta plus c. So from the reference triangle we get sine theta is equal to 3x over 9x square plus 16. Therefore cosecant theta is equal to 9x square plus 16 over 3x, and then substitute into the answer 9x square plus 16 3x cube plus c.
Okay, for question 3, you need to see the denominators here below. So you need to factorize the denominators. And I get is x squared plus 4 x minus 1. So you need to replace this below the integral. So x minus 1 is linear factors, and x squared plus 4 is quadratic factor. So partial fraction can be used here. So this is a partial fraction, and before that you need to cancel out this denominator by multiply both sides with x minus 1 and x squared plus 4, and this can cancel out. After that you can get this y, and then you need to expand the right hand side. After you expand you get this value. After that you need to assume that x is equal to 0 and substitute into the question, and you will get this one. After that you need to find they have two unknown values, so you need to find a. So you can assume that x is equal to 1. After you assume x equal to 1, you will get a equal to 3, and then get back to this question, and then replace a as 3. After that, you get c equal to 8. And then you need to assume another value, which is x is equal to -1. And you will get b equal to 2. This is my mistake, okay? After you get b equal to 2, you can use substitutions, integrate substitutions. And then you need to separate this. After separate, you need to use a substitution, which is, you can see here, you need to use below here as u, then you get du. And then to integrate integral, you need to find a value a, and into find value a. After that, you can 3 divide x minus 1 is equal to this one, and then this one equal to this one. You need to replace the value as u because it's substitutions. And then this one also, and then this one you need to see appendix, so you get tan, reverse tan, and then substitute value a. After substitute value a, you get the final answer.